done in two different ways. Observation or carrying out an experiment a certain number of times. So let's think about experimental probability. Experimental probability is going to be different than our standard probability that we would expect. Okay. The reason being is because it's from an experiment. Okay, so I think what we'll do is carry out a little probability experiment, and I'll get you to put this all into practice, but we'll discuss it here first. So I toss a coin, and here are my results. So obviously we're tossing a coin. I found I got a head 32 times, and I got tails 18 times. Now, what's the probability of getting a tail using this coin? So, first of all, my question to you is, how many times did I toss this coin? How do we work out how many times I actually tossed the coin up in the air? Sarah?
Well, you have to plus 32 and 18 together, and that would give you 50.
Lovely. So I tossed this coin 50 times. I found that I got 32 heads and 18 tails. So the question is, what is the probability of getting a tail using this coin? Does anyone want to suggest what they think might be the answer? Abby?
I haven't looked at the answer, but I know how to find the answer. Is that okay?
Okay.
Okay, so, are you recording? Yes. So, I think you have to double 18 and 32. You double it because 50 is half of 100, and 100 is the total percent that you want out of. So.
All right, you are doing something even fancier than we need to. So remember, probabilities they don't have to be percentages. Okay, so they can be fractions. So if you were looking at this situation, tell me what you think the probability of getting a tail would be. How many tails did we get?
You got 18, so...
And then how many times did we toss the coin? How many times did we toss the coin?
I think it would be 32%.
We don't have to do it in percentages.
I don't know how to do it exactly.
Okay, so Kaya?
Is it like, well, I'm not worrying about those numbers right there,
Well,
but
no, we have to worry about these numbers.
well, I was going to say half because it's like,
But this is what I'm saying. Experimental probability is a little bit different.
so would it be 25?
No. No. Maya?
Maybe 32 over 50.
Careful, we're looking at probability of being a tail. 18 over 50.
I can't find it in my
Jay, come on, percentage, please. Oh, well, hang on, we'll talk about that in a second. When we decide once it is presented, I'll straight to you, okay? So, it says, what's the probability of getting a tail using this coin? Now, Maya, you're going to explain to me where those numbers came from. That's you. So we added them up. Oh, so 50 told us what? What was the information that 50 told us? Georgie?
How many times I get
Yeah. So that was how many times we tossed the coin in total. Yes? So we got that by adding those two numbers together. And then obviously the probability of getting a tail using this coin, we look to see how many tails we got. Remember, probability is the number of events we're interested in over the total number of events. Okay? So the number that we're interested in over the total probability. Now, that's written as a fraction. It's the easiest way to do it when we have a situation like this. And if we had wanted to change that to be a percentage, Jade, what was the percentage?
It was 36%, and how you did that would, you would go 18 divided by 50, and then you would, 36 was 0.36, in decimals, and then I just rounded it to 100 because that's what we do it if you want.
Multiply that.
Right?
Yeah, that's absolutely right. Now, the alternative way of doing that, so rather than if we didn't have a calculator, we could have also done this. Because you know that 18 over 50, Abby helped us out here, didn't we? What did Abby say we should do?
You should double both of the numbers because that your total percent number would be 100.
Exactly.
Doubling.
So if we wanted it as a percentage, we could have multiplied both of these two numbers by 2 and got 36%. Okay? Jade used her method with a calculator. You could have done it without as well. Alright? So this is great, girls. This is all working together and recapping our probability, our fraction and percentage work as well. Alright, so that's our answer, 18 over 50. We don't need to simplify it because it's a probability topic. Okay, any other topic with fractions we would have to, but probability is the one time we don't. Now, here comes a different kind of question. It says, is the coin fair? Well, first of all, we have to explain, well, what does that mean? Is it fair? What do we think is it fair means? Max, what do you think is the coin fair means? Okay, hang on. I'm gonna change my question to you. I'm gonna say, right, we're using this coin, and I will give you $5 if it lands on a head. No, on a tail. Are you going to be happy about that? So if I said I'm going to give you $5 if it lands on a tail, and I'm going to give Pasika $5 if it lands on a head. Is that fair?
Yeah.
That's fair?
No.
Yeah. So Madison's happy about that.
No.
Smart.
Trying to explain why I'm not happy because you should be giving Madison, you should be offering her more money because there's less chance of her getting the tail, and then Pasika, there's more chance of her getting the 5, so she would get the lower amount of money because it's a less likely chance of her.
Okay. Why is it less likely that she's going to
Because
get?
it's only 36% or 18 over 50, and the other one is 32 over 50, and 32 plus 32 and
64.
64, and so 64 and 36, you kind of want the higher numbers. You should be offering Madison more money because there's a less likely chance she's going to get it.
Okay. Kaya?
But isn't it like, it's like, because sometimes it could land on tails rather than heads. So isn't it a fair chance because it's not like 2 heads on both sides? So it's like, it's heads of one and tails of the other, so it's even chance that it can land on one.
Okay, now, the situation is, that I specifically said using this coin, okay? So this is the coin we have to use. And so we found that the probability of getting a tail using this coin is 18 over 50, okay? So we found that this particular coin has 18 over 50. So we go back to the question, is it a fair coin, Jay?
It's not really a fair coin because it might have been made differently because the experiment carries out that on the heads it's most likely to drop on the heads than on the tails, so that probably means that the coin is not really like balanced out.
And so we know it's not, it's more likely to land on the head and less likely to land on the tail. Because what would we expect our probability to be? What would we expect it to have been, Sarah?
Like 50-50 chance.
Yes.
Because, like, if you just, like, clear out everything, like, you would just guess that it's 50-50 chance because it's, like, you learn of either.
There's 2 sides and 1 head and 1 tail. So we would expect it to be 1/2. So going back to the question, is the coin fair? No, it isn't. Because it is more likely to land on heads than on tails. The probability tail is only 18 over 50, but head is 32 over 50. So if we've got space, I'm going to say for a fair coin, it should be 25 for each. Okay? So do we understand the concept of being fair?
Yeah.
Yes, so we would, if something was to be fair, we would expect that we would have an equal chance of winning. Now, if I had 6 of you and I rolled in, what do you think you not see? Can you not read any of it?
No, I have copies. It's the. Oh wait, never mind. No,
I think this is all I've written. Sarah? Or should I pause it 3 times?
How do you know that they didn't like look at that? How like they what should I say? Because normally you do that. Maybe like they didn't do like that. Maybe they just did.
Okay, so that brings in lots of discussion points. So when it comes to probability, we have to try and make sure that our situation that we are conducting our experiments in is as fair as possible. And that means that it's going to always be the same person tossing the coin, it's always going to be the same coin, we're going to ask them to try and toss it to the same height, and so on and so forth. So you would have all of these conditions that you would need to meet when you're conducting these experiments, okay? And sometimes it, like if you're just pulling something out of a bag, it makes no difference who's doing it or what bag it is, as long as it's the same bag. But for stuff like this, then it would make a difference. As I said, it could be that one person does an experiment and they get a completely different situation. Maybe their tail comes up a lot more often. It means that their coins have slightly different probability.
Or the way they're flipping it.
And possibly the way of flipping it, but it's more likely to be the coin. So what I want you to understand here is that experimental probability means that we're not looking at just how many sides does the coin have and how many are heads. It's actually looking at how many how many trials did we have and how many were we successful for.
Yeah.
All right, I'm good.
Thank you.